Let's take a minute here to see where our work with sequences crosses over into what we've discussed previously with functions. So I want to look at this function over here first. This relation, this set of ordered pairs, has been graphed on the coordinate plane here to the left. As you know, this relation is a function because every input has exactly one output. And I know that graphically that this passes the vertical line test. There's no vertical line that's going to touch this graph in two places. So let's think about this set of ordered pairs as a sequence for a second. If I consider that the ordered pair 1, 2 is actually referring to the first term of a sequence being 2, then the second term of the sequence is -1, and the third term of the sequence is -4. Fourth term of the sequence is -7. So the x value here tells us what term of the sequence we're considering. So you could almost call it a sub 1 and a sub 2, a sub 3 and a sub 4. If we begin to think of our function in this way, using sequences, then we can write an equation for this function in the exact same way that we write an equation for a sequence. Let's first consider what our common difference is. It appears that this continues to decrease by 3 each time for each term of the sequence, and it should go on and do this forever. So if the common difference is 3, let's move back for a second and see what is our phantom term. What is the 0th term? So if I go 3 the other direction, that 0th term would appear to be 5. Oh hey, would you look at that? It's right there too. The 0th term is 5. We can tell that from the relation, as it's already been graphed over here, that the 0th term is indeed 5. So now I can, if I think of this as a sequence, I could write it as a sub n is equal to -3n plus 5. But now let's jump back into this function world and say, I want to write this as a function. Just simply use function notation. F of x is equal to -3x plus 5. And here you have written a function to match this relation. Let's try it again with the other one that we did in class. So here you have your relation over here, and again let's consider that the first term in the sequence is 4, and the second term of the sequence is 6, and the third term of the sequence is 8. This appears to have a common difference of 2. Which means that that phantom term, if I go back to the other direction, would have to be 2. We'll compare what you see over here in the set of ordered pairs. Yes, the 0th term is 2. So if I wrote this as a explicit formula for the sequence, I would have to write it as a sub n is equal to 2n plus 2, because 2 is the common difference. I would write 2n, but 2 is also the 0th term, so I would add 2 at the end. We'll now just convert this into function notation. F of x is equal to 2x plus 2. And again, we've written a function for this set of ordered pairs.